Hi, this is JD, and in this lecture we're going to be looking at applications in graphing quadratics equations. Specifically, we're going to look at how to graph quadratic equations. So here's a preview of what we're going to go over, and it's not necessarily going to be in this order, but we're going to go over the vertex formula, x-intercepts, y-intercepts, min and max, and axis of symmetry. Now, something that's very important to quadratic graphs is figuring out how many x-intercepts you have. So you can figure that out by using what's called the discriminant. The discriminant is b squared minus 4ac. Now, the way that I'm going to use it is I'm going to put it underneath the square root, and then you can kind of see what type of solutions that you have. So notice that if it's a positive square or positive non-square, you have two real solutions. And on this chart it gets a little specific. But both of these are going to be two real solutions. If it's 0, then you have one real solution. Now, rational, irrational. Rational just means that you can write it as a fraction with no square roots, just a whole number over another whole number. Irrational means it has a square root in it. And you can kind of tell the difference between the two when you take the square root of it. Now, if it's negative, then it's two complex but not real solutions. Now, complex but not real means that it's imaginary. And if you recall from the previous units that we just recently went over, when we took a square root of a negative number, it was not real. So same thing's going on here. Now, greater than 0, equal to 0, less than 0. So if b squared minus 4ac is positive, then you have two x-intercepts. This is when it's two real solutions. When b squared minus 4ac equals 0, that means you have one real solution. On a graph, you're going to have one x-intercept. When you have b squared minus 4ac and that's negative, then you have no x-intercepts, because they're two complex but not real, meaning imaginary solutions. And even though I'm touching on imaginary numbers here, imaginary numbers are actually really helpful in physics. So, but you don't need to know that, but just know that they do have some applications. There's some applications to complex but not real numbers. Alright, so example number 1, what we're going to do here is we're going to go through each of these, and we're going to use the discriminant to determine the number and type of solutions of each quadratic equation. And at the same time, we're going to also figure out the number of x-intercepts that they have. So we're going to use the discriminant, which is b squared minus 4ac, and I'm going to put it underneath the radicals so that that would indicate, that'll give you a clue on what the type of solution is. So here, just like before, a is in front of the x squared, b is in front of the x, and c is by itself. So see, I plugged it into the discriminant, which is 4 squared minus 4 times 1 times 4. This would be 16 minus 16 16 minus 16 is 0. Square root of 0 is 0. And that tells me that I have one real solution and I have one x-intercepts. Let's look at the next one. So we have 5x squared plus 7. A would be equal to 5. Now there's no x here, so that would indicate that b is equal to 0, and c would equal to 7. And then just plug those in. So we have 0 squared minus 4 times 5 times 7. 0 squared is 0. 4 times 5 is 20 times 7 is 140. So that's a negative 140. Notice we can stop there because this will give us not real solution. So we know that it's going to be two complex but not real solutions. That will also tell us that there's no x-intercepts when it comes to graphing. For letter C problem, we have 3x squared minus 2x minus 2 equals 0. So A is equal to 3, B is equal to negative 2, and C is equal to negative 2. So we'll plug those in. Notice with my B that I plugged it in using parentheses, and this should be a multiplication symbol. Let's just write that in there. Should be 4 times 3 4 times 3 times negative 2. This would be 4, and then this is negative 4 times 3, which is negative 12, times a negative 2, which would be plus 24. So that would be 4 plus 24. That gives us a square root of 28. That doesn't simplify, so we know it's going to be two real solutions, but you can say it's two irrational real solutions. Here for simplicity, I'll just put two real solutions. That will give us two x-intercepts. Not pretty x-intercepts, but still give us two x-intercepts. Alright, so now let's look at the vertex formula. The vertex formula is very useful because it finds the vertex Now when you graph f of x, and f of x is the same as y, it's function notation, you have ax squared plus bx plus c. And that's a parabola. Parabola is another name for quadratic function. Now this vertex formula, draw a little picture here. You have a parabola. The vertex is on the bottom right here. Now this is going to be either facing up or facing down. I'll give you a little hint later on how you can tell just by looking at it. But the vertex is here is either going to be the bottom of the valley or the peak of the mountain. So either on the top or on the bottom. And there's a formula when it's in this form. So this just means that your x is negative b over 2a, sometimes that's h, and then you have f of negative b over 2a, which just means that you take whatever you find here and you plug it into the function. And you'll see that when I work out an example. So let's look at an example. Example number 2. So we're going to find the vertex. We're going to do that first. And then we're going to find any intercepts. So we're going to look for both the y-intercept, which is really easy to find, and then the x-intercepts, if there's any. So to find the vertex, we're going to use that formula, negative b over 2a. So b is this 4 right here. A is this 4. Just plug it in. So that's negative 4 over 8, which simplifies to negative 1/2. Then you take negative 1/2 and you're going to plug it in. So that's what f of negative 1/2 stands for. You're just plugging it in. So where there's an x, I'm going to plug it in. So this is negative 1/2 squared. This is negative 1/2 and 3. And we're going to do order of operations here. So this would be 1/4 times 4, which will give you 1. 4 times negative 1/2 gives you a negative 2. And then plus 3. So that's 1 minus 2 plus 3. This will give you 4 minus 2, which is 2. Just rearrange it, make it a little bit easier. So now my vertex, this negative b over 2a is my x coordinate, and this 2 that I found, f of negative 1/2, is my y coordinate. So the vertex would be negative 1/2, comma 2. Vertex is very helpful when it comes to graphing and finding a max or a min. B, we're going to look at the intercepts. And first we're going to find the y-intercepts, which is really easy to find. Just to recall, y-intercept is when your x is equal to 0 and your y is some number. So there's our function. Then replace all the x's with 0. This zeroes out, this zeroes out, leaves you with 3. So y equals 3. So the y-intercept would be 0, comma 3. And these all give us very good points to use when it comes to graphing a parabola or a quadratic function. So we're going to look at the x-intercepts and then we're going to graph. So x-intercept, if you recall, is the opposite of y-intercept. So your x is some number and your y is 0. So you set it equal to 0 and then you find your x's. This is where you're going to use either the quadratic formula, solve by factoring, any of those other methods that we looked at in the previous units. So we're going to use the discriminant, which is, and we're going to use that first. And this will determine the number of x-intercepts, because you can have 0 x-intercepts, 1 x-intercept, or 2 x-intercepts. So you can have that, and this is part of the quadratic formulas, because so even if you, let's say that this ends up being a little bit more work, you can always use that as part of the quadratic formula so that you can find the x-intercepts. So we have b squared minus 4ac, so b is 4, a is 4, and c is 3. Let's plug all those in. This would be 4 squared minus 4 times 3. So this gives you 16. And then you do the multiplication. This would be 4 times 4, which is 16, times 3, which is 48. So it's 16 minus 48. You can see that this gives us a negative number. So it gives us a negative 32, so that we know that there's no x-intercepts. So let's graph. We found the vertex to be negative 1/2, comma 2, and it looks like on this graph we're counting by 2's here, so it's kind of close. And then we found our y-intercept, which is 3. Let's plot that. And then let's graph. Alright, so let's look at some main things when it comes to quadratic graphs. So some main things include determining if it has a max or a min, then finding the max or the min. Now the maximum or the minimum would be the same as finding the vertex. And then finding the axis of symmetry is helpful because the axis of symmetry, parabolas, you can split it down the middle and it's like a mirror image. So if you find one point on one side, you can find another point on the other side. And you can tell by these first things if it has, you know, a maximum or a minimum, or really this first question, is by looking at the A. So if A is greater than 0, which means that it's positive, then it's a happy quadratic. It would be facing upwards like this because it's positive. Now if it's negative, which means A is less than 0, so another way of saying that A is negative, then you're going to have a sad quadratic. Sad parabola, happy parabola. And this has to do with that A that's in front of the x squared. And you see below, this is an example of, this is just x squared. So it's a positive A, and you can kind of see how it faces up like that. And this is negative x squared, so it faces downward. And this is true for all quadratic graphs. So if it's positive, it's going to be facing up. If that A is negative, it's going to be facing downwards. Now, just by looking at it, you know that the vertex is going to appear on the bottom. And so that would be a minimum. Just by looking at this, you know that the vertex is going to appear on the top, and so that's going to be a maximum. And this maximum and minimum is in reference to the y's on the graph. So if you were to compare all the y values, this would be the highest with the second graph. With the first graph, if you compare all the y values, then what's on the bottom with the vertex is going to be the minimum. That's what it's referring to. And then the axis of symmetry goes through the vertex, and it appears as a vertical line, which is in the form of x equals some number. So let's look at an example of this, and let's go through these. So it says find the following of f of x equals negative x squared minus 2x minus 3. It says determine if it has a maximum or a minimum. Just by looking at the A is negative, so it's a sad face. And so since it's a sad face, then it's going to be a maximum because the vertex appears on the top. Second question, or second instruction, it's asking us to find the maximum or minimum. So now we're finding the vertex. So negative b over 2a. So negative b is negative 2 and a is negative 1. This would be 2 over 2. Or negative, oh, that's incorrect. That changes everything because it should be positive. Yeah, at least it didn't change it here. So let me show you what I'm referring to. So negative, the opposite of negative 2 would be a positive 2. This is 2 times negative 1, which would be negative 2. So positive 2 over negative 2 gives us a -1. Then you take the -1 and you plug it in. So this would be negative parentheses -1 squared minus 2 parentheses -1 minus 3. -1 squared is 1, so this would be -1 plus 2 minus 3. -2 plus 2 is going to give us a -2. And so our vertex, our x is -1 and our y is -2. So that's our vertex. Now the axis of symmetry is the vertical line that goes through the vertex. So the axis of symmetry would be the x, you would take the x coordinate of the vertex and it would be x equals whatever that is. And here it's x equals -1. Now let's look at a graph really quick of how this appears to be. And so here on this graph right here, let me change to a laser pointer. See on this graph, the vertex is -1, -2. Here it's counting by 4s. 4, 8, 12, 16, 20. And so you can kind of see that, okay, it appears in the right place. You have the axis of symmetry. The a less than 0, it's negative, so it is facing down. Alright, so in the previous unit, we went over how to solve quadratic equations. That's useful here because that's a way that we can find x-intercepts. And so we looked at solving by factoring, which was covered in not the previous unit, but a couple units before that, or several units before that. Last week we looked at square root property, completing the square, quadratic formula, which is x equals -b plus or minus the square root, b squared minus 4ac, all over 2a. Got that memorized. And then this week we looked at quadratic graphs. We looked at the vertex formula. The vertex formula appears on the, is it the min or the max, so it appears on the very bottom or on the tippity top. Then we looked at x-intercepts with quadratic graphs, and using the discriminant, you can tell if there's no x-intercepts, one x-intercepts, or two x-intercepts. Y-intercepts, very easy to find. Just plug in 0 for x and then just solve it. We also looked at min and max within reference to the leading coefficient in front of the x squared, the a, and that if a is negative, then it's facing downwards. It's a sad face when a is negative, so that would be a max. And when a is positive, that's a happy face, and so the vertex is going to be on the bottom, which would mean that's a minimum. And going straight through that vertex is the axis of symmetry, which is simply just x equals, it's the vertical line, x equals whatever the x coordinate is. And that's it. That marks the end of this video. If you have any questions, put them in the comments below. Thank you, and I hope you have a wonderful day.